guys, welcome to this video where we're going to have a look at just some examples of solving differential equations. Now the kind of differential equation that we're looking at is the one that we discussed in class today. So it is of this type where you have the rate of change of a quantity with respect to time is proportional to the quantity itself. And that kind of differential equation or proportion statement can always be turned into an equation where we have some constant here. Now I'm going to show with an example that this constant is actually the interest rate or the percentage change that's happening. It's not going to be a proof, but it will be an example. Now before I do that though, let's take another example from your workbook. So I'm looking here at question 253 from page 236. Now what this one is saying is that we've got some money to invest, $15,700, and we've found a bank or an institution that's going to give us 9.8% per annum. Now per annum means per year. Okay, and that interest rate is compounded. Now in the situation where it's compounded, like we looked at in class today, it's going to be a situation of this kind here. Okay, and the question is, well, if we invest 15,700, how long it's going to take before that money triples in value? Okay, so let's start off. What we're going to do, I'm going to call V the value of the money that we've got. So V equals the value or the amount of money. So the rate at which the amount of money changes with time depends on the amount of money that's invested. The more money you invest, the quicker the rate of change. Okay, with this compound interest. Okay, now as we saw in class today, the solution for this will be a e to the power of kt. So V equals a e to the power of kt. Okay, and we went through those steps in class today. Now taking that solution, what we're going to see or we're going to have is that k is this percentage rate here. Let's just accept that for now, that k is always the percentage change. Alright, so I can put that into our equation, and you put it in as a decimal number. So 9.8% is 0.098. Now before we can find out how long it's going to take to triple the value, we need to find out what this constant a is. Now one piece of information we've got here is that this 15,700 is what we're starting off with. So in other words, when t equals 0, V is that 15,700. That's what we're starting off with. So if you substitute this in, we'll quickly see that this is going to be the value of a. Putting t as 0, we get e to the power of 0, which is 1. Okay, so therefore, as I was saying, a is going to be that 15,700. Okay, so just moving over to the right here a little bit. Our equation now is V equals 15,700, putting that in place of a, e to the power of 0.098t. Right, so having got that equation, let's now figure out how long 15,700, how long it's going to take for that to triple in value. Now triple 15,700, you get 47,100. So when will the V be equal to this? So what we're effectively after here is time, the value of t that would make this true. Let's fix up that little error. Okay, so the first thing I'm going to do is move this 15,700 over here. So we need to divide by 15,700. Well, we know that that is triple 15,700, so we're going to get 3 here when we divide 15,700 into 47,100. Now, to get rid of e, we're going to use the inverse function, which is natural log. So I'm going to take the natural log of 3. If I take the natural log of the right hand side, we get 0.098t, and so t must equal the natural log of 3 divided by 0.098. And if you calculate that with your calculator, you get approximately 11.2, and this will be in years. Why? Because we were talking about per annum here, so it is in years we're talking about, and that's been rounded to 1 dp. Okay, so that's another example. Once again, let me know tomorrow if there's anything on this that you're not too sure about. Now, I'm going to have a look at the example which was given on page 235. So this is not a question, it was the first example. So why am I doing example 1 as an example? Because it's a useful one to show why this k is going to be basically the percentage rate of change. Okay, so in this particular example, we've got here, if the rate at which an investment in art appreciates means gains in value, depends upon the value of the artwork. So they're saying, let's call P the value of the artwork. Personally, I would have used a different variable, but let's go with what they've got. So the rate at which the value of the artwork changes with time depends on the value of the artwork. Okay, and we're asked to find out what K is. Well, they put an I here for interest rate. I'm just going to call it K like we did in class today. So find the annual rate of appreciation of the artwork, okay, which was purchased for 12,500. So at the beginning of time that we're measuring from, the value of the artwork started off at 12,500, and we're told was valued at 14,300 5 years later. Now, whenever they give you this t equals 0, this is a way that we can actually find out the value of a. So the solution to this, as we saw in class today, is p equals a e to the power of kt, and it's starting at t equals 0 with p being 12,500. We get the same kind of statement that we had in the previous example. E to the power of 0 is 1, so a is that 12,500. Okay, so here we're now going to substitute that into our equation. And now let's substitute this other piece of information here, that when t equals 5, p is 14,300. So 14,300 equals 12,500 e to the power of 5k. Now, solving this, we need to divide 14,300 by 12,500. Okay, and that is going to give 1.144. Take the natural log of both sides like we did in the previous example, and then to get k on its own, we need to take that natural log value and divide that by 5, and what we end up with is k being 0.098, 0.0269, and that is a percentage is 2.69%, or close enough to 2.7% if we round that to, I suppose we can call it 1 dp, or perhaps 2 significant figures might be more accurate. Okay, so what this example does demonstrate is that this K value that you have here is the percentage rate of change, as we can see from this worked example with the information given here. Okay guys, I think that's probably enough by way of examples at the moment. So once again, if there are any questions on this, make sure that you're asking me tomorrow. Otherwise we'll be continuing some questions on this in class time, and we'll see you there.